Okay, I'm going to walk you through how to do one of the beams for activity 3.2.6, and then you'll need to follow the same technique for the other three that you need to work on. So here we're given this web page, and I showed you in a previous video how to look up the information on this web page to pick the beams you need, and you will use MD software. This is a partial framing floor plan for a new hotel that we're going to calculate, and we're going to do these 4 parts. I'm going to do the interior beam for you, or with you, and then you're going to do these other 3. And down here at the bottom, it gives us criteria that we're going to be using. What the dead load is, the live load, all this information we're going to be using later on during our calculations. The next page shows this whole list of things. Basically, this is what has been broken down for you on the following pages that look like these. So this list right here just corresponds to this information. You don't have to do something separate here. It's all worked out over here for you. Once you've worked out all 4 of these pages, you do need to come back and check your calculations using MD Solids and print out the shear and moment diagrams and the slope and deflection diagrams. I'll show you how to do that in another video. So we're going to start here with the interior beam. In our diagram, we're looking at one of these interior beams here. One of the first things we're going to have to figure out is the tributary width for this beam. And so it goes from the middle of this one to the middle of this one. Remember we did this a few sections back. Well, if it's 6.8 here, it's going to be 6.8 for my tributary width, and then I need to convert that just into feet. Shuffle my paper down here. So the first thing we need to do is draw our beam out that we're talking about, and this is our interior beam. We haven't calculated this load yet. I'll show you where they got this load. But it is 18 foot wide. We know it's 18 foot long here. We're drawing one of these beams. We're assuming pinned on one side and roller on the other. And we know what our loads are from here. 50 pounds per square foot, and live load is 100 pounds per square foot, which they got from the code. So first we need to calculate our dead load. This is what we were just given on our previous page, 50 pounds per foot squared. And then this is the tributary width that we just found on the other page. Multiply those together to get pounds per linear foot. Do the same thing with our live load, 100 pounds per foot squared, and calculate. Now to find my total load here, I need to add up these 2, and we get roughly this, so we're going to say 1,000 foot and round it off. Okay, the second item. Calculate the end reactions and maximum moments. So our reaction forces, this formula right here is actually coming from 3.2.4, where we use the different formulas along with the MD solids. Remember doing that? Well, we have these formulas, and this formula is going to vary depending on what kind of load it is. This is the formula for a uniform load. It'll be different when you do the other 3 parts depending on if you have point loads or not. So then I get this number, comes from right there, that's my total load, and my length is 18 foot divided by 2, and I use my calculator to get the answer. I also want to find the maximum moment, and again this formula is coming from this last activity we did, and it'll vary depending on what our loading is. Plug in my load, my length squared, and work this out. That's it for number 2. Number 3. This equation right here was given in the PowerPoint we just saw for using our factor of safety. So to find my nominal moment that I need, this is the number I got from right here. This was the number that's always used for my factor of safety for moments. It was given in the PowerPoint. Multiply. Number 4. Here's my other formula that I had from my PowerPoint. And we're going to rearrange this by just dividing both sides by Fy. So that I get zx is equal to my moment divided by my Fy. So this number is my moment right there. And then I need to convert that to inches. And then I'm going to divide by 50,000. This 50,000 right here came from the given criteria. And it was right here, Fy equals 50 psi. Now I need to go to my table to look up and decide what size of beam I need for this right here. So I'm looking for where Zx is greater than 16.2. Well, this is the same table that I showed you how to use online, and I've just snipped the part that we need here. And I want to go down because I want to find the smallest beam possible that I can use. And on this one, when I'm looking at the properties, you may have to open up your window more because it's all the way on this side over here. So I go all the way down and I find this one for Zx. This one is the smallest one I can find that's still bigger than 16.2. If I take and follow this one back across, I'm going to highlight it. I find that this is a W12 by 14. A W12 by 14. Now we aren't sure that this one's going to work. It meets this requirement because it's Zx is bigger than the one I just calculated, so that's good. And then also from the table, I'm going to write down these 3 values because I'm going to need them in a minute. Ix is right here under properties, and I just come down here and get it, 88.6. And then I need these 2 from the dimensions. So I click on the dimensions box to come back to the dimensions and scroll all the way down until I get to the 12 by 14. That's the one I'm looking at. And what I need is I need the thickness of the web and I need D. So the thickness of the web is right here and my D is right here, and here they've just converted it to the decimal. So I need to write those 2 numbers down because I'm going to use those.